Scott Reed.
Okay, thank you, Michaela, and welcome everyone to the webinar today. I'd like to thank you for taking time out of your busy day to attend it. As Michaela mentioned, the webinar is titled Belimo Energy Valve Optimization Simplified. On this short webinar today, we're going to cover some of the issues that the energy valve solves in the marketplace in terms of low delta T. We'll look at a little bit of the scope of how big low delta T is, and we'll talk about some of the onboard functionality that we have in the energy valve that helps solve some of those issues, and some additional tools that we provide to help making solving low delta T easier and more user-friendly. So without further ado, I'm going to go ahead and get started. So why do we focus on energy optimization? Well, because there's a large opportunity for improvement. Buildings are an integral part of the global energy system, and they use about 40% of the global energy, so that's fairly significant. 25% of the global water, 40% of the global resources, and emit 1/3 of greenhouse gases. And overall, the HVAC system uses about 39% of the building's energy. So it's a good low-hanging fruit for energy optimization, and the Belimo Energy Valve is suited very well to accomplish that efficiency improvement. So when we talk about particularly the HVAC system, what we like to focus on with the energy valve is low delta T syndrome. There's numerous articles out there published about low delta T syndrome. Many articles have been written, many have been understood, many have been passed to us, we've passed to our customers. And if you do a quick Google search, you can see you get about 22 million results on 0.37 seconds for low delta T syndrome. So it's something that's very prevalent. A lot of buildings and plants suffer from this, and it's something that the energy valve, once again, is very well suited to solve. So let's talk about what may cause low delta T syndrome. Now, this is not an all-encompassing list of what can cause low delta T, but it gives you a little bit of a background. So the first one that I like to talk about is coils and valves are not sized properly. So coils are inherently and typically oversized, sometimes as much as 30% with a safety factor. Also, same thing with valves. Valves are particularly oversized as well. Well, here we're talking about particularly pressure-dependent valves. So pressure-dependent valves, as you may know, are sized on a CV calculation. And when they calculate that CV and go to the product catalog, sometimes that correct CV or that exact CV is not available. So what does one do? One chooses a larger valve. They don't want to undersize the valve and have an underperformance, so they oversize the valve. So right out of the gate, both coils and valves are inherently oversized. Systems are not dynamically balanced. Here, this is related to pressure-dependent valves as well. So not using pressure-independent valves. So these pressure-dependent valves are at the mercy of pressure fluctuations within the system and are going to have a negative effect on control based on those fluctuations in pressure. Once again, on the coil side, coils foul and degrade with age or lack of proper maintenance. If a coil is not properly maintained, if it isn't cleaned properly in terms of removing dust off of the surface or internal scaling, it would have a negative impact on the heat exchange capability of that coil. Also, over time, coils just start to physically degrade. They're made of metal, and that metal over time can rust. And even time during service, there could be instance where the product is, or the coil is damaged during service. And these coils are designed with a very specific geometry between the tubes and the fins. And if that geometry is changed, that once again is going to have a negative effect on the heat exchange of the coil. So essentially, what we're talking about is too much water being delivered or over pumping that coil with, in a sense, a low delta T syndrome effect. So we'd like to talk now about the solution, which is the energy valve. So I'd like to break down the components for you in a very unique and brief way to help you understand what the capabilities are within this product. So first, I'll talk about the actuator. The actuator is our most advanced actuator in our platform. It has an onboard web server that allows us to set the parameters of the valve and can also allow us to connect to this valve remotely over an IP network. So if there's valves located all over the world or all over the United States, I can connect to them directly sitting at my office here in Danbury. There's an onboard data logger, a data logger that stores 13 months worth of trended data on flow, temperature, valve position, energy, and that data is very valuable. We're moving to a very data-rich time with the advent of things like IoT, which we're going to talk a little bit about more later. So the data is really a powerful tool that the Energy Valve outputs. It has BACnet both MSTP and BACnet IP, as well as Modbus, allowing it to integrate into systems network. Also has a standard analog signal for control as well. And we have another feature called Glycol Monitoring, which I'm going to talk a little bit about later, which we have the ability to output the actual glycol percentage in the system with a single Energy Valve. The flow meter. The flow meter is a very robust design. It's an electronic flow meter, ultrasonic transit time. So you now actually have the actual flow rate, which is a very good advantage over some products that may use valve position and pressure to estimate what the flow is. Here you actually have the actual flow reading utilizing this flow meter. We're going to talk a little bit more about those later, but it's the robust design is good because it helps in terms of maintenance. There's no moving parts like an impeller type flow meter that can clog or jam over time. So it helps with the reliability and the maintenance factor of this product. The temperature sensors. We have two platinum-based RTDs. So now that we have a flow meter and we have two temperature sensors, we can now extrapolate BTUs. So now we not only have a control valve with some additional functionality, we also have a BTU meter as well. So we're combining a lot of function within the Energy Valve. Additionally to that functionality is the DT manager, or the Delta T manager logic. And what that does is maintains the appropriate Delta T across the coil, eliminating low Delta T situations or low Delta T syndrome they were talking about before. I'm going to talk a little bit more about that in the upcoming slides, but that is all on board right in the actuator. No additional functionality, or I'm sorry, no additional software to download, no additional programs to install. It's all ready to go right when it's shipped from our factory. We also have cloud optimization now built into this product. The Energy Valve is now an IoT device that allows us to optimize via our cloud, once again leveraging that very powerful data that is output from the Energy Valve. We also have another thing called power control. So this valve can be controlled to a flow set point, or what we call a Vmax, the flow limitation, but could also be controlled to a Pmax, or a power set point, or a power limitation. So it's another functionality as well. So as you can see, what we've shown so far, there's a lot of functionality built into this product overall. So let's talk a little bit more about that low delta T and what that looks like in terms of saving pumping energy. So I have a very simple chart here. It's describing the relationship between flow and delta T. So the y-axis on the left, we have power and BTUs. We have GPMs on the bottom. And the y-axis on the right, we have delta T in degrees Fahrenheit. So as you are probably aware, there's many data points for coil power and for delta T curves, but we've just simplified them with one single line to help explanation purposes. So let's look at a couple of flow points. So we have one point here operating at 65 GPM, and we show about a 10.5 degree delta T, generating 325,000 BTUs. So what you can see is it's starting to level off on that power curve, and the actual Energy Valve has determined that the best delta T set point for this application here is at 12 degrees. So at the 65 GPM, we're actually creating a low delta T scenario. So what the delta T manager is going to do is going to modulate flow through that valve, bringing it back to approximately 55 GPM and producing 320,000 BTUs of power output. So we're serving the load in that space, but at a lower flow rate and optimizing the delta T closer to design. So what does that look like in terms of horsepower and overall energy? So let's look at a couple of points that we looked at before. So the difference between 320,000 and 325,000 BTUs is a 1.6 increase. In terms of GPM, we have an 18% increase. So what does that mean in overall energy? Well, we know that in order to calculate our overall horsepower, we need to cube our GPMs, and then we find out that it cost us an additional 65% in pump horsepower to get less than 2% increase in BTUs. So 65% in pump horsepower or 65% in additional dollars. So you can see those additional BTUs that we get at the top end of the curve, and we know that coils are typically very inefficient at higher flows, come at a pretty significant cost. So now let's talk about some of the features that we have that can help you optimize your system and help leverage these tools to help you manage your delta T and help optimize your valves overall. So our cloud services is something that we launched recently, and it really helps our customers to help understand what's going on with their valves and helps them to optimize them as well. So I'd like to talk to you now about our 6 cloud services that we offer. The first one is optimization of delta T and flow settings. As we talked about earlier, we understand that coils over time may degrade and their performance may not be achievable of design, but you may not know what the best delta T set point is to operate that coil on. Connecting that valve to the Belimo cloud will allow you to propagate that data to the cloud, and the cloud can actually determine the best delta T and flow set points for that valve, even push them directly to the valve if desired. We offer a performance report. That performance report has key indicators of how the valve has been operating, how much energy has been used, and that is provided on a quarterly basis. And we're going to take a little bit closer look at that in the upcoming slides. In terms of online support, this is a more robust experience here that we provide with our cloud services, as we can now directly connect to our valves real time to understand what's going on, so we can provide our customers with a more robust experience and a faster support experience than they would with traditional methods. Software updates. This one here is very significant. Imagine, for example, you have over 200 valves in a building and they needed to be updated for specific functionality increase or enhancement. Now, 200 valves across a building or multiple buildings would take significant time to update. These valves could be up on the roof, these valves could be up in the ceiling, down in mechanical rooms, behind cabinets. So it takes a lot of time, just one, tracking those down, and two, updating those. Connected to the cloud, all the updates are automatically pushed directly to the valve with the push of a button. Those updates can also be reviewed before loading, similar to what happens on your cell phone or your computer, where you can view those prior to loading. We increased the warranty for another 2 years. The standard product warranty is 5 years, but we increased it to 7 years with a connection to the Belimo cloud. And as we talked about before, that very valuable data is now available for the lifetime of the product. We said earlier on the actuator, it stores 13 months of trended data, but connected to the Belimo cloud, that data is lifetime. So one single, secure repository for all of your system data. This is a quick example of the performance report. You can see on the top left, it shows where the valve is located, the valve name. On the bottom left, there's some energy performance, so we can see energy performance year over year to understand how the delta T manager has been operating in terms of an energy performance. On the top right, we have the status showing how the valve has been operating, if there are any issues with the valve. We use kind of a red light, yellow light, green light scenario. So green would be everything is good, red would be there's a pretty significant error and something needs to be addressed. Typical error could be excessive air in the system, and the system need to be bled off to remove that air. And we also have the current settings, if it's set for what the delta T set point is set for, if the delta T manager is on. So one quick report to help understand what's going on with the valve, and that's provided automatically on a quarterly basis. Another feature that we provide, which is an extension of our Belimo cloud, is what we call the energy flow map. And what that does is it allows you to load a floor plan of the building and drop the energy valves that are connected to the Belimo cloud in that floor plan. And you can understand from an energy perspective how those valves are performing. So you can look at the overall energy. So the way certain energy managers would use this is they would load their floor plan, put the energy valves in their respective places in that floor plan, and look at where the largest loads are first and attack those to see if there's any potential for optimization. Maybe some of the valves, the delta T manager could be set a little differently to help optimize and get a little more efficiency out of the valve, reducing pumping energy like we're talking about before, or just have an overall understanding of the loads and how they're distributed through the building. We also provide, as you see on the top right, a dashboard to show, what's happening overall. So a total heating energy, a total cooling energy by building, and you can also break it down by floor. So you can understand from a floor perspective where the largest loads are as well, and for a building perspective where the largest loads are. And we also have errors as well. So if there's any problems with the valve, it shows an error indication. So that dashboard gives one quick summary of what's going on with the operation of those overall valves. Down below, we also have some charting. So if you understand total power, flow, valve position, and delta T, so you can look at it from a visual perspective of how those valves are operating. Some people prefer to look at it on a chart, and it gives them a little more visibility and a little better understanding of how the valves are operating, and we provide that as well. So those products there are primarily cloud products that require an internet connection. For those customers that prefer not to connect their valves to the internet, they prefer to do their analysis locally. We have a product that we're working on for release later on this year that we're calling Belimo CLEAREDGE. And what this is a device that helps to leverage that system data off the BACnet network and perform some analysis on that data based on what it's seeing in terms of operation for the BACnet network. So that's kind of the key requirement. Let's talk about some of the key features. So it has an automated BACnet detection and point mapping of the energy valves. So with a push of a button, all the energy valves are found on the BACnet network and pulled directly into the CLEAREDGE system. So it doesn't, some buildings have over 20,000, 30,000 devices. So this actually filters through each of those devices and pulls out only the energy valves and loads them directly into the CLEAREDGE. It works on both BACnet IP and BACnet MSTP. We also provide an aggregated dashboard similar to what you saw on the cloud dashboard. So key metrics, total flow, total energy. If there's any operational errors with this, it's sortable by column, so you can get a good granular view of what's going on with each of those valves in terms of snapshot view. We'll also provide power curves and charts. So once again, a nice visualization of what's going on in terms of operation. This also has the ability to calculate the best delta T set point for you built right into it. So it will look at that system data and calculate a best delta T set point, again, if it is unknown or design is unachievable. So with that, we also provide a flow and energy savings calculator. So how much energy has been saved utilizing the delta T manager, for example, and then what that translates to into a savings, a financial savings, which is very important to help understand. So that's based on the current pumping configurations of each site. So that's a very valuable way to help prove the operation of the energy valve in a specific site. And one of the last features I'm going to talk about is continuous automated delta T optimization. So what it does is has a routine that will continuously look for this best delta T set point and apply that to continuously optimize that valve's performance throughout the cycle or throughout its operation. So once again, kind of automatically optimizes each energy valve that's installed on that site. So those are for things that kind of do it for you. For those that like to do it themselves in terms of data analysis and leveraging that rich data that's coming off the energy valve, we also provide a data analysis tool. So this is basically a macro in Excel that pulls the data directly off the energy valve actuator, which comes off in a CSV format. So basically pulls it in and you can understand, how the valve has been operating from a control standpoint. Is it mostly open? Is it mostly closed? What mode has it been operating in? How often has the delta T manager been engaged or not engaged? It also provides a waste zone calculator to understand, how much the energy valve is saved in terms of operation with the delta T manager engaged. And we also have the ability to provide a financial savings as well. The one example that we show here, we show about a 59% savings or 225 gallons that was saved by utilizing the delta T manager enabled in the energy valve. So once again, we have multiple ways to simplify the operation of the energy valve and also to make it easier to help prove and validate the operation. So those are kind of after the valve installed. You may want to understand what your savings could be before the valve is installed. And for that, we provide the energy valve savings estimator. And the savings estimator is a tool to help provide just that. how much energy savings and how much financial savings can be saved by increasing your delta T. So you input certain parameters on what your current delta T is and your future delta T, information on the plant, types of number of chillers, operating hours per day, and operating hours per week, and so forth. And it will actually output a financial analysis over a 5 to 20 year period of what the savings could be by implementing the energy valve. So it's a very useful tool to understand going in what the valve could save you. So we have kind of a way to understand going in, and then another way to validate after the valve has been installed. So very, very valuable tools to help aid the product. The next thing I'd like to talk about is back to product features. So our advanced ultrasonic technology. We're starting to transition on our larger sizes to our ultrasonic flow meter. We've already been using that on our smaller sizes, our 1/2 inch through 2 inch MPT valves. So for our larger sizes, for both energy valve and EPIV, we're moving to our ultrasonic design. This gives us a lot of good advantages. It gives us temperature and glycol compensation built right into each of these flow meters. So as the changes in temperature and glycol concentration change, we maintain our accuracy with this product. We've seen statistics that show up to 30% deviation for sensors that do not have this capability built into it. It also has another thing called Glycol Monitoring, as I talked about very early in the presentation, that has the ability to output the actual glycol percentage of the system. So it's a very valuable thing to know, because there's some unique benefits that can be realized by understanding the current glycol concentration. So let's talk a little bit more about those. So in terms of glycol, so glycol concentration that is below the design concentration, there's some natural risks there of the system freezing. And if the system freezes and pipes break, you could have costly repairs throughout that system. So it could also damage the building. So if a valve were to break over a server room, for example, that could be a very costly repair to help rectify that situation. Glycol concentration above the design limits has a really bad effect on the heat exchange, for one, and for two, it increases your overall pumping efficiency, because as you increase your glycol concentration above design, that media becomes thicker. That thicker media requires more pumping energy or more pump head to pump that around the building and increase your pressure drop. So that there increases your overall pumping energy. Once again, on the heat transfer side, there could be situations where excessive glycol in the system will impede the ability to meet discharge air. Coils are designed for specific glycol concentrations, and if it's too high, you could actually have a situation where you do not meet the discharge air because the heat transfer performance is so degraded by excessive glycol concentration. So overall, you would have a result in comfort as well in the space. So setting it at the ideal level increases our overall heat transfer, increases our pumping efficiency, and reduces our overall operating cost. Now, this is a very unique feature within this product, because to understand what that glycol concentration would be, it would require an additional device called the refractometer. So that refractometer, one, you would have the cost of that refractometer to install the product, the cost of the product itself, and also another additional control point to control that. Where now with the energy valve, you have that all integrated right into one device. So no additional components to install. The glycol percentage actually comes back as a backnet point, so it can be understood by the system, all done with one single device and one single set point, optimizing your system and reducing your overall installation cost. So to summarize here, I talk about optimization simplified along with so many benefits. We talked about the Delta T Manager and the options that we have there for helping understand the Delta T. We can use the data analysis tool for one. We can use our Belimo Cloud to help understand what the best Delta T set point is. We can use Belimo ClearEdge. We talked about how that Delta T management really helps save pumping efficiency. So there's a lot of pumping efficiency to be achieved by optimizing and eliminating that low Delta T. We talked about the flow meter and the ability to measure glycol. We talked about the temperature and glycol compensation, how that maintains our nice accuracy and our repeatability. We talked about the user interface and the integrated web server and our cloud services and how it makes it easier from an operational standpoint to have that connectivity anywhere from any location. And we talked about our cloud services and how they can help the customers understand what's going on from an operational perspective. And we have some additional features there in terms of additional warranty. At its core, the energy valve is a pressure independent control valve. So it eliminates additional balancing valves because it's now performing that hydronic balancing, eliminates additional circuit setters. So it really is a lot of things built into one compact package. I'd like to leave you on this slide here, which is the award-winning Belimo Energy Valve. The Energy Valve has won over 25 awards so far. I'm not going to go through all of them in detail. We're, of course, very proud with the Energy Valve here at Belimo, but when it's recognized in the marketplace, it's something that gives it even that much more credibility and makes us even more proud of the product in the marketplace. So I just wanted to give a quick recognition of all the efforts that our marketing teams have done, all the efforts that our innovation teams have done, our product management teams to help really, and our sales teams, of course, to help make this product successful in the marketplace. Turn it over now to Michaela, who's going to talk to you about our social media platforms.
Yep, so our social media platforms, keep informed, follow Belimo on the various sites. We're on LinkedIn, YouTube, Facebook, Twitter, and Instagram. We have now reached the end of the presentation where you are able to ask questions to Scott directly. So if you would open up your question box, type in your question, I will read them aloud. We are limited for time, so if we don't get to your question during the live webinar, we will be reaching out to you later on. Scott, are you ready for these questions?
I am ready. Fire away.
Okay, the first question, does the flow meter need to be calibrated on a regular basis?
No, it's a great question. The flow meter does not need to be calibrated on a regular basis. It's calibrated over the lifetime of the product, primarily because it uses no moving parts. It's an ultrasonic technology, so there are no parts to wear or degrade over time.
Okay. Next question, is the energy valve a product to solve the low delta T syndrome, or is it only a product / tool to help diagnose that there is a problem?
It can be used for both. So it can help determine when you install the energy valve, one of the benefits of the energy valve, particularly the web server, it shows where the current delta T is and also captures that delta T in the data file. So you can understand over time what your delta T is. So if you know your delta T, your design delta T is 12 degrees, for example, and you're seeing a consistent 10.5 degree delta T, you know that you have a low delta T syndrome. So then you could actually implement the delta T manager to manage and optimize that delta T back to the design 12 degrees.
Okay, next question. The PGBL shows the half-inch to 2-inch valve remote temp sensors length is 8.8 millimeters short, 3 millimeters long, or 3 millimeters long. Is there a possibility to purchase accessories to extend this length?
There are additional lengths that are available, and they're in the accessory section of the PGPL, which is in the back of the butterfly section, section 19, I believe.
Can the energy valve operating mode be selected through BACnet objects?
Yes, it can. Yep. Why
is Glycol model not available in the catalog for EV size above 2.5 inches?
That's a good question. So in order to have the Glycol models, you need to utilize the ultrasonic flow sensor. The current design right now is electromagnetic. As I mentioned, we're just starting to transition into those away from electromagnetic to the ultrasonic. So when that transition is complete, we'll be updating the PGPL with those models.
Is there an annual fee for data collection service? If so, what is it and what is included?
No, we do not offer fees for our cloud services, which would primarily be this data collection service. We offer it as a value add to our customers but for purchasing the product and working with Belimo.
Do all models of the energy valve include indication of the glycol concentration percentage?
That's another good question. So we have separate models for the glycol, and they have a -G suffix in the actuator. So for example, on the half inch, instead of it being ARX24-EV, it would be ARX24-EV-G to indicate the glycol capability.
Okay, I'm going to do a last call for questions. If you should have any questions after the fact, you can reach out to me and I'll pass them along to Scott. Just bear in mind, we are taking a short summer break and we will kick off our webinar series back up in August. So Scott, are you ready for those last couple of questions?
Sure.
Does the glycol compensation take in account the dependence of heat transfer on the convention and the flow's dependence on viscosity?
The glycol. Can you repeat that question?
Does the glycol compensation take into account the dependence of the heat transfer on the convention and the flow's dependence on viscosity? Concentration.
Yeah, I'm not sure I completely understand the context of that question. Rather than give an answer that I'm not quite understanding the question for, I would prefer just have that question sent to me and I will reply directly to the customer because I feel there might be some back and forth on that question.
Sounds good. And last question, where is the other temperature sensor located?
So it depends. So if you have a flange model, you have an integral temperature sensor built into the flow housing, and then the second one would be remote. If you have the MPT models, both temperature sensors are remote, so 2 external sensors.
Perfect. Well, thank you so much, Scott, for that excellent presentation, and I want to thank you all for participating once again in our webinars. We look forward to having you join us at a later time, and I hope everyone has a great day. Thank you so much.
Thank you all.